Hi, this is Mark Kemper with EMS, and in this video we're going to show the 3D scanning process for vehicles for things like paint protection film, wraps, and other aftermarket accessories. So for this video, we chose the new Creaform HandySCAN Black 3D scanner. The reason we did so was a few things. One, portability. Most of the people that are doing this type of work need to go out to a car lot or a dealer and scan the vehicles right there on site. Many times they're outside. Also, as you see here, this vehicle is black with a lot of chrome. We've got some translucent surfaces, and it's large. So that's about all the challenges you're going to run into. So we'll see how well this scanner does on a vehicle like this. So we're going to get set up. We'll take you through the whole process of scanning and then working with the software to prepare the data, and then the actual downstream software that does the flattening and unfolding and prepping of the data for whether you're doing a wrap or you're doing film. Okay, so we're starting to get set up. We've plugged the scanner in. The cable that comes with it's about 10 feet. There's optional 25 and 40-foot cables. So depending on the size of the vehicle, you may want a longer cable. That just helps you move around. Usually out in a car lot, we'll have a portable PC stand because we do need to be running plugged into a PC. Here in the shop, we've got a nice rolling cart. But typically, if you go out to a lot, we have some kind of stand or something we can put the PC on so we can look at it as we're working. So we're all plugged in. And then really the next step is to target the vehicle. Now, this scanner does require targets. Once you target it up, it makes it extremely fast to scan. Also holds better accuracy by using targets. So we'll get some targets set up. We'll show you that process, talk more about what they are. All right, as far as the targets themselves go, there's three main options that we use. There's the adhesive targets, and they come in a light and regular adhesive. There is non-adhesive targets that basically don't have anything on them. And then there are magnetic targets that would stick to anything magnetic. So depending on where we're applying the targets on the vehicle, we'll choose the right type of target. And we'll go ahead and show you that now. So here on the hood, we'll go ahead and use the non-adhesive targets because they're pretty much laying flat. We don't need an adhesive. Now, theoretically, you could also use the magnetic targets here. But some cars have carbon fiber or aluminum hoods, so the magnetic ones wouldn't matter. But either way, you could use either one. And you just put them out in a random pattern about every 4 to 6 inches, and you just kind of spread them out and lay them out. The nice thing about the non-adhesive ones is you can just move them around if you need to, and when you're done, you can just kind of wipe them all off or sweep them all off and reuse them. For the magnetic targets, it's the same thing. You just put them in a random order about every 4 to 6 inches apart. The scanner will use these for positioning, and this will make more sense when we get to the actual scanning. But the magnetic ones are great because you can reuse them, and they just will stick to anything magnetic on the vehicle itself. And finally, we'll place the adhesive targets every 4 to 6 inches on all the vertical and non-metallic surfaces. The box that they come in, they self-dispense out of very easily, so you can put them on the vehicle very quickly. Okay, so we've got the vehicle all targeted up. It took about 15-20 minutes to fully target half the vehicle. And considering the size of this vehicle, that's actually not too bad. So now we're really ready to start on the 3D scanning process.
All right, to start the actual 3D scanning process, you literally push a button on the scanner, you hold it about 10 inches away from the surface, and you just start slowly moving back and forth. And what's going to happen is the scanner is going to basically do two things. It's going to use those targets, those reflective targets, for position, and it's going to emit 22 laser lines, and that's what picks up the shape. And you notice here we're picking up dark and shiny, we're picking up chrome, translucent surfaces, and for a lot of scanners this is a real challenge, if not impossible, for them to do. So the fact that it does this so quickly and with such good results is pretty unique in the industry. But what happens is the laser lines, as they distort, as they change shape over the shape of the vehicle, there's two cameras or sensors on the scanner, and they're looking at the shape of those lasers, and through a process called triangulation, that's how it's picking up the 3D shape. The targets are purely for position, just so the scanner knows where it is positionally. You can almost think of like GPS. The targets are like the satellites, and the scanner is like the receiver. So using that same type of triangulation process, the scanner can track where it is in space while the lasers are picking up the shape. So it's like digital spray painting. You just keep moving around. You try to hold it somewhat perpendicular to the surface that you're scanning. That's always going to give you the best return, the best results. And you just keep moving around the vehicle until you get everything. And visually, you just, you take a look at it as you're scanning. At any time you can stop scanning, look at the computer, spin around the model, and make sure you've got everything. Now, you can't overscan the part. If you go over the same areas over and over, it doesn't hurt anything. You could certainly underscan it, so that's why you definitely want to check your model out as you go along or when you finish. And if you've missed some areas, you just can go back and just fill those areas in. So it is a visual check. But you can see we just keep moving along to get the whole surface. And again, we're doing dark, we're doing shiny, we're doing translucent, and it has no issues with any of those surfaces. So you just keep moving around the vehicle until you have the whole thing captured, and then you're done.
So that wraps up the 3D scanning process. Now, if you were just doing paint film protection, where you're doing the front of the car, you could easily set up and scan a vehicle like this in under an hour. Now, we did the entire vehicle, and that probably took 2 to 3 hours with setting up, targeting, scanning, and then removing all the targets. But still pretty impressive when you think about it. A handheld scanner in a small case. You could travel out to a dealer or a customer, scan a large vehicle that has dark, chrome, shiny, translucent, very challenging surfaces. You could do it outdoors and do that in a few hours with just the handheld scanner and a laptop is pretty impressive. So what we'll do next is actually take a look at the scan data, and we'll show how we're going to prepare that scan data, clean it up, and prepare it for downstream software applications that will use this scan data to do what they need to do for their processes. So now that we're done with the 3D scanning process, we can take a look at the actual scan data here. And as you can see, it looks very good. We set it to a 1mm resolution. Now what comes with the scanner is what's called VXElement software. And that lets you do some basic editing, some basic hole filling, and so forth. And you can adjust the resolution after you 3D scan it. You can adjust it up or down. 1mm, I think, is plenty of resolution for what we're going to be doing. And you can see overall it looks pretty good. Now we're going to show how to trim this up for some paint protection film, and typically that's going to go on the front of the car. If we were doing a wrap, obviously we would want the whole vehicle, or at least where the wrap was going to be.
So since we only scanned half the car, we're going to mirror it over. Now, if I was just doing the front paint protection, I would just scan the front of the car and not even do the rest of it. But we went ahead and scanned the whole thing so we had it. And the advantage of that too is now you've digitally archived it, so if you were going to do a wrap later, you've already got it. Now, the standard VX Element software doesn't do what I'm about to do, which is actually trimming up by curves. We're going to do this in the VXModel software, which is some add-on software that you can get with the scanner. But you could do this in other software products as well, such as Geomagic Design X, Geomagic Wrap, and then basically any software that can bring in an STL file and trim the data to curves. Okay. So the first thing we're going to do is let's get rid of some of the data we don't need. So I'm just going to come in here in a top view, and I'm just going to window in on the area I actually want to keep. And then I'm going to inverse the selection and then just delete what I don't want. Okay, so you can see what we have here. So just the front of the vehicle. Now the next thing I need to do is mirror the mesh. Okay, and when you scan, you always want to go beyond the center of the vehicle so that you have some reference geometry on the other side. Okay, so I'm going to click Mirror Mesh, and I'm going to draw a line, and you just want to kind of eyeball right down the center of the vehicle, and then hit Apply, and then we'll hit OK. So what we end up with then is a mirrored copy of the front of the vehicle, like you see here. Okay. Now we could further trim this up and delete data if we want. This is fine. We'll work with this. Now, before we start creating the cutout patterns, I'm actually going to create a plane that we're going to use later, but I want to do it now before we start cutting up the vehicle. So I'm going to say Mesh Symmetry Plane and basically do the same thing that we just did. Again, get in the view. We'll draw a line. So basically we're just going to build that same plane, but this time we are going to create it as a plane entity that we actually keep. When we mirrored it over, it doesn't actually keep the plane. So we're basically making a copy of that plane. Okay, so what we end up with, as you see here, is a physical plane right down the center of the vehicle. Okay, we can close that. And for now, we can just hide that. Okay, so by having that plane, I've only got to create the cutout for half the vehicle, and then we'll mirror it over the plane. Okay, but again, we needed this geometry over there to create that plane. So what you're typically going to do now is you're going to look at this and you're going to figure out, where you want the paint protection. Obviously, we have the headlight here that we don't need. We don't need the chrome intake here, and we've got the turn signals here. So, and this is a good one because it's a fairly complicated shape. So what we're going to do is we're going to create a curve, and I'm going to start right up here in the middle. All right, so we're going into the Create Curve command here. We're going to set a deviation of 0.5 millimeters, and we're going to fit right on the mesh. And what that means is it's going to fit this curve within a half a millimeter. Now, everywhere we're dropping a hard point, the curve will fit right through that. And you can see here as we go around like a corner, we'll definitely want to drop more points to have more control on that. And then in the flatter areas, we can space them out. But basically, we're drawing where we want the edge of the paint protection film to be. And again, when you get up into corners, you're going to drop a few more points so you get a nice round and have a little more control. And then where you have more shape, or less shape, I should say, you can space them out. So it's really up to you. And you'll see the curve will update as you're adding more points, constantly trying to calculate how to, flow the curve through those points. But the curve will want to take kind of the path of least resistance so you get a nice smooth curve. But again, the key thing here, though, is as we're dropping a point on the mesh, it's going to then force the curve to lay on the mesh, or really on the surface of the vehicle, in 3D space. Okay, so the points are kind of hard points, and then in between, the curve is going to lay on the mesh, but you know, it's going to kind of follow, again, that path of least resistance. So you just continue to walk around all the way around the where you want the edge. You can zoom in and zoom out and rotate around to get exactly what you want. And this typically takes just a few minutes. This front fascia on this vehicle is, you know, got quite a bit of shape and cut out to it, so you get an idea what it takes. So we'll let this speed up the video here. You can kind of see the process going all the way around. Okay, so now as we're coming up here to the center of the vehicle, what we're going to do is go just a little bit beyond it, and then we're just going to kind of do a gentle curve and come back, because we'll mirror this over. That will save us from having to trim the you know, the whole vehicle. We only need to do half because it's symmetrical. Now we're going to actually trim this out, this small piece out, and then actually fill this hole back in later. But we need to trim it to get rid of the this grill area here, or this plastic decorative piece. We've got to get that all that data trimmed out, and then we'll fill that hole back in. We'll explain that here in a second, but we're just going to come up all the way around here. So just like on that bottom area, on the bottom side of this trim piece, up here on the top side, we're going to do the same thing. We're going to make this gentle, we're going to go beyond the center, and then just make this gentle curve to come back around, because we want kind of the start and the stop of our lines to be nice and smooth. So, you know, just curving it around, we'll do that like that. So once that's done, now we can go ahead and we're going to use our trim tool to actually trim the mesh to that curve. So we select that command, we select the curve, we tell it what side we want to keep. In this case, we want to keep the inside, and it's going to trim all that 3D scan data to that curve and do it very accurately, because that curve sits right on you know, right on that mesh. Okay, so that's our first cut. Now we want to do a cut here around the turn signal, and again, it'll be the same thing. We just go in, create a curve, and we just pick where the edge of our paint protection film would be. And you know, where you create these curves is really up to the installer or whoever's designing this. You know, you basically decide where, you know, what you want covered or what you don't, and you just create these trim lines. So same thing here. We'll just go all the way around and select the edge, and you know, for time purposes, we'll speed this up till we get all the way done. And then we're going to do the same thing again. We're going to tell it we want to do the trim, and in this time we're going to keep the outside instead of the inside. So those are our two major trim outs. All right, so the next thing we're going to do is trim out for the sensors. So this vehicle has sensors on it for, you know, parking and so forth. And we're going to create the curves like we did last time, but we're going to do something a little bit different because I want a perfect circle, but I'm drawing a sketch on a, you know, on a 3D surface. So what I'm going to do is just draw the circle fairly close, and then I'm going to trim it out and then go and edit the boundary. So this will make sense. So now I go to my trim command, but you can see I can't draw a perfect circle freehand, but I need to get it trimmed first. So we trimmed it out just like we did before, and let's go ahead and do the next one over here. So again, we're just going to try to eyeball where the kind of the edge of that sensor, where it basically starts to curve down. We're going to go ahead and just draw a circle as close as we can. It doesn't have to be perfect, and you'll see why. So there's 3 sensors on each side, and we'll go ahead and trim those all out. And there's one more here over on the side. And you can see this one's inset quite a bit. Okay. So we'll go ahead and pick the points on this one. And again, we're just trying to kind of get a point up on that edge that's fairly close. And then we hit OK, and then we trim it out. So final curve. Oh, we picked the wrong curve there. There we go. because that other curve had already been trimmed. Okay, so now we're going to use this boundary command, and basically we're going to tell it to make a circle. We have to trim it ahead of time so that there's something there, and then it's actually going to fit a perfect circle on that boundary. And if we turn off the curve, you can see now we have a perfect circle, but you got to have it trimmed out, and then it'll fit a circle to it. So a two-step process, but then we have a nice, you don't have to do this unless you want it to, have a nice perfect circle, which is just going to look better, but not absolutely required. So you can fit different shapes to things once you've trimmed it out. Okay, so we'll do this one as well, and then we'll do the last one. So those are the sensors. So those are all now trimmed out. All right, so our next step is to mirror over the mesh data, and that is why we had created that plane earlier, because we are going to now use that, and we are going to basically mirror over everything we've created and then trim it at the center line, and then we'll just hide the original. So now we basically have the thing on both sides. So again, you only have to do one side, and then you mirror it over, and you've got the whole thing. Again, this assumes it's symmetrical. And then the one last final step is to fill in that hole. So we trimmed it out because we needed to get rid of, the data there that was the plastic, trim piece. But for this particular vehicle, we're actually going to want to fill that in for the Exactflat process, and then that one will probably be manually trimmed out, because otherwise there's just such a thin strip down at the bottom, it would be hard to put on the vehicle. So this is where you get into just how this stuff would actually be installed. So for this application, we're going to fill this hole back in, and this might be the one time where it might be a manual trim out process. So the only thing left we have to do is now export this 3D model as an STL file, and that'll go then straight into the Exactflat software, where they can do all the flattening and creation of the trim lines.
So here's the Escalade bumper that was scanned. And take a look at this. The first thing I'm going to do is I'm going to weld vertices. So welding the vertices, just make sure all the UV coordinates are pointing in the right direction. So I'll highlight that, just hit enter on my keyboard. Next thing I want to do is I'll probably decimate this mesh a little bit more. So I'm going to go here to remesh the scan. I'll hit enter on my keyboard. I'm going to toggle these on, and I'm going to change this to 90, the boundary edge for the smoothness to 90, and I'm going to say we want 3,000 vertices, so we'll go from 39,000 to 3,000, about 10%. So I'll just hit start, and I'll go through and start working on that. So you can see now the mesh is actually getting decimated. The fidelity's still, the quality's still there, but the scan's gone from about 40,000 down to 3,000 triangles. So I'll just hit OK here, accept that, so you can see that we still have good quality. And I'm going to go into my shaded mode. And the next thing I'm going to do is I'm going to our next tool, which is our flattening tool. I'll just select the mesh again for flattening, hit enter on my keyboard, and we'll select the pattern view and turn off the other two views. And we'll go into our top view here so we can take a look. I'll zoom to extents to show the mesh. Again, I will go into our shaded view, and you can see the strain on the mesh here. If I go into my options and go into Exactflat options and go into the legend, you can see the legend. It goes from 0 strain, which is pure white, to red, which shows above 20% strain. Exactflat's a two-step flattener. The first step gives us a projected flat, so it hasn't been optimized yet. That's what I'm going to do now. This mesh actually has what we call flip triangles in these corners, so I'm going to check for flip triangles using the flip triangle, and what I'll do is I'm going to actually pelt it, and I'll check again for flip triangles, then I'll optimize. Flip triangles are just material that's flipped over on itself, or material that's actually, if it was fabric, it would be laying on top of itself. So we're just going to go through. We've checked, and now we're flattening, and this will go fairly quickly. Process is finished. Just hit OK here, and what we would do is we'll send this off to create a DXF. So DXF can be cut or printed using a plotter. So simply hit export to DXF, and I'll just do this test. And if we go in here, open up the DXF file, so just close this. We'll go into DXF right here, go up to our desktop, and we have one called test. Just open that up, and here's the DXF file ready for cutting. There's two layers on these DXF files. There's a cut and a seam, so I can just turn the seam off and go ahead and plot it like this. It also has a grain line, which is this white line. It doesn't get printed, but if it's bothering you, you can simply go here to the layers and you can turn off the grain line, just like that. Anyway, that's how you create a DXF file from a flat scan.